This is the help video for the quiz 1.11. So for this quiz, you're going to need to remember all of your mapping rules. So here they are one more time. Why is this not clicking? Okay, there we go. For translations, you want to do x plus or minus a number to move it right or left, or y plus or minus a number to move it up or down. To reflect across the x-axis, the x value stays the same, the y value changes signs. To reflect across the y-axis, the y value stays the same and the x changes signs. To reflect across the line y equals x, you switch the order and change the signs. For a 180-degree rotation about the origin, that's the same as reflecting across both x and y axis. You would just change the sign of both. A 90-degree rotation counterclockwise, you would switch the order of x and y and you would change the sign of y. For a 90-degree rotation clockwise, you would switch the order of x and y and you would change the sign of x. All right, so you'll probably have to refer back to those while you work on the quiz if you don't already have them memorized. So, the first type question says, what are the coordinates of 2, -3 after a counterclockwise rotation of 90 degrees about the origin? So I'm going to go back here and I'm just going to steal this mapping rule right here. Counterclockwise mapping rule says, change the order of x and y and change the sign of y. I'm going to go ahead and write that down. Take your point, change the order, so y would come first, and then we want to change the sign of y. Okay, so we're just going to apply that to our ordered pair. So our ordered pair is 2, -3. We want to take this y value and we want to put it first. And we want to change the sign from negative to positive. And then we want to take our x value and we want to put it second. And so those would be the new coordinates. All right, this one says, drag and drop the answers into the boxes to correctly complete the statement. The sequence of transformation that maps triangle DEF to triangle D', E', F' is a blank followed by a blank. Okay, so let's look at this. So some of the things that I like to check for first, I like to see if the orientation has changed. So for example, you can notice E is on the bottom here and E' is on the top. So that could be a reflection. But then if I check out D, I notice that D is on the left, and then over here D' is on the right. If it was just a reflection, like let's say across the x-axis, the D would still be located over here. So the orientation has changed, so that's something that kind of lets me know that it's going to be a rotation. So that's what I'm going to look at. I'm going to check out the rotation options. So one of them is rotating 180 degrees about the origin. Well, let's try that. If we rotated 180 degrees about the origin, we have to change the sign of x and y. So for example, let's start with E. It's at -2, -4. Our E' would end up at +2, +4. So let me go over here and try to graph that 2, 4. All right, let's try D. D is located at -2, -1. If I did a 180-degree rotation, I would have to change the sign of x and y. So then D would be located at 2, 1. And then if I did F, which is at -1, -1, I would have to change the sign of both of those, and it would leave me at 1, 1. So just by rotating 180 degrees, I'm left with this triangle. And so then I hope you notice that you still have to do one more transformation. And in this case, it looks like we're just shifting it or translating it to the left 1 unit. And if we just counted each one, F to F, that moves 1, so on and so forth. So those would be our correct answers. We want to rotate 180 degrees, and then we want to translate left 1. So this one would go there, and that one would go there. All right, graph the image of the given triangle after the transformation with the rule of change the sign of x and keep y the same. So remember, just by looking at the mapping rule, I already know that I'm reflecting across the y-axis because the y stayed the same and we changed the sign of x. But if you don't automatically know that, it's no big deal. You would just write down each ordered pair. So this ordered pair is located at 8, 2. And then I want to apply my rule where I change the sign of x so it becomes -8 and y stays the same. So to plot this point, I would go to -8, way back here, 2, 3, 4, 5, 6, 7, 8, and up 2. Alright, so that would be my new black point. Now we could do the same thing for the next one. This one's originally located at 4, 7. If I apply my rule, it says change the sign of x and keep y the same. So my x value would become -4. My y value would still be +7. So I would go back here, -1, -2, -3, -4, +7. And then I could do the same thing for the green one. Hey, I want to show you one other way you could do it. If you recognize that this was a reflection across the y-axis, you could also count the spaces to get to the line of reflection. So I could count 1, 2, this is 3 spaces to get to the line of reflection. So I would have to go 1, 2, 3 in the opposite direction to get that new point. So that's another way you could do it. If you realize it's a reflection, you could just count the spaces to the line of reflection. But that would be your new triangle. Alright, so again, we're going to graph a new triangle after the transformation with a rule of adding 3 to the x value and subtracting 5 from the y value. So let's just start with a point. Let's start with 7, 3. We want to add 3 to the x, and we want to subtract 5 from the y. So my new ordered pair would be at 10, -2. So of course I'm going to run off the graph again, but 10, -2 would be somewhere over here. And then let's try the next one. If we did this ordered pair, it's located at 2, 2. And it says I want to add 3 to the x value and subtract 5 from the y value. So this would end up at 5, -3, which that point you can kind of see. And then let's do the last one. This one right here is located at 4, -3. Again, apply your rule, so you're going to add 3 to x and subtract 5 from y. And your new ordered pair would be at 7, -8. 3, 4, 5, 6, 7, 8. So somewhere down there. And this would be your new triangle. Okay, the coordinates of the vertices of triangle JKL are those. And then the coordinates of the triangle after the transformation are these. And we want to drag and drop the answers to correctly complete the statement. Alright, so we're trying to map the original triangle to the new triangle, and it's got to be 2 transformations. So let's see what series that would be. So this is kind of like requires guess and check a little bit. But the first thing I'd like to do is I'd like to just look and see, okay, how are these numbers changing? The first thing I notice is the x went from positive to negative here, the x went from positive to negative here, and the x went from positive to negative here. Alright, so that's pretty important. If I'm changing the sign of x, there's a really good chance that I might be reflecting across the y-axis. So let's just guess and check that. If I reflected across the y-axis, this would become -3, 4. This would be a -3, 1. This would be a -1, 1. And then let me look at my y values. My y values went from 4 to -5. So that went down 9. Here it went from 1 to -2. So that only went down 3. Okay, so I really don't have any way to make that work. So that was an incorrect guess, and I'm going to try again. So since that didn't work, I have to kind of reevaluate. And what I noticed is if this was a -4, that's really close to -5. And if this was a -1, that's only 1 away from -2. And if this was a -1, that's only, again, 1 away. So if you change the sign of x and y, that's actually a rotation of 180 degrees. And then we can go from -4 to -5 by subtracting 1. We can go from -1 to -2 by subtracting 1. -1 to -2 by subtracting 1. So the two transformations here would be a rotation of 180 degrees and then a translation 1 down. And I know it's going down because I'm subtracting from the y value, which is what's moving it down. So again, these are kind of just guess and check while you're working on them until you can figure it out. And that is it. Good luck on the quiz.